Alright, so in this video, we're going to learn how to use the reduction formula. This will be, I'll have four different examples. The difference in the different examples is the alpha. It'll be in different quadrants in each video. I'll have a video where alpha's in the first quadrant, another one that's in the second, then another one third, another one fourth. So you can check them all out. So what we're doing is we have uh, sine x plus cosine x, and we have a coefficient for each one here. And what we're going to do is we're going to rewrite it as a single sine function. Instead of having two trig functions added together, it's just going to be a single one. So if alpha is an angle in standard position whose terminal side contains AB, then a sine x plus b cosine x is equal to, and this is going to be the square root of a squared plus b squared times sine of x plus alpha for any real number x. So we know how to get this number here in front of sine. X is just going to be x, and then we've got to figure out how to find alpha. Now, depending on what textbook you're using, or how your teacher tells you to do it, there's different ways to find alpha. There's also, you've got sine alpha is equal to b over the square root of a squared plus b squared, and you've got cosine alpha is equal to a over a squared plus b squared. Okay, you can use either one to find alpha. I just always like to use tangent alpha as b over a. And look, all this is, look, if you have an angle here, and it doesn't matter what quadrant it's in, and say it contains, the terminal side contains the point AB, so we know this is A, this is B, okay? And look, this side here is the square root of a squared plus b squared. See, Pythagorean theorem. And if this is theta, I mean, look, that's where these come from. Okay, so if we call this a squared plus b squared, if we call that, say, r equals that, okay, you probably recognize this. Okay, we can say r equals a squared plus b squared. That's the hypotenuse of this right triangle. Here's your angle. This is the side opposite, and this is the side adjacent. So we know that what tangent alpha is what opposite over adjacent, b over a. Look at this. The sine, well, I know I'm using theta here, but it's the same thing. Theta alpha, doesn't matter which angle you use. But look at this. The sine of the angle, what's sine? Opposite over hypotenuse. You see that? Opposite over hypotenuse. And look at cosine. The cosine of this angle is adjacent over hypotenuse. So that's all that is. Okay, so whichever your teacher tells you to use, just use whichever one. Okay, but like I said, in these videos I'll just use tangent alpha equals b over a. That, to me, that's the easiest one to do. And plus a and b are given to you, so you don't have there's not a chance of, in case you make a mistake calculating this, then your angle will be wrong also. So just use what's given to you there. Okay, all right, so let's go ahead and get started on the example. All right, so example 2. It says use the reduction formula to rewrite 3 sine x plus 4 cosine x in the form a sine x plus c. Now, the directions, they say a sine x plus c, and the formula that we just looked at, remember this a here, that was your square root of a squared plus b squared, and the c, that was alpha. Okay, I mean, it doesn't matter what they use, but just know that that's a, this whole thing here, and c is alpha. Alright, so let's go ahead and get started. So the first thing we need to do is we need to find a. But let's go ahead and identify what A and B are. Well, we got to find big A. Let's find out what little a and B are. So A is 3. That's the number in front of sine. B is 4. That's the number in front of cosine. Okay. So now we can get A is equal to the square root of 3 squared plus 4 squared. So that's going to be what? 9 plus 16 is 25. And the square root of 25 is 5. Okay. So there's A, A, the number in front of sine. And now we've got to find our angle. So remember, tangent, and we'll use C, that's the alpha that was in the formula. Well, that's what? That's B over A. So that's B, which is 4, over A, which is 3. All right. And then before you do the inverse tangent of this, we need to see what angle, I'm sorry, we need to see what quadrant our angle is in. So if we plot this, okay, let me do that in a different color. If we plot this, if I plot the point 3, 4, because remember it passes through the point AB. Okay, so 3, 4. So if I go over 3 and up 4, I can see my angle is in the first quadrant. So you might, if you've watched the other videos, we found a reference angle, but we don't need to find the reference angle here. Well, actually we are, because the reference angle is the first quadrant angle. Okay. All right. So in this case, I'm going to get C is equal to, and then the inverse tangent of 4/3, that's not one of those special angles, so we'll have to punch that into our calculator. So I do inverse tangent 4 divided by 3, and that is going to give me 53.1 degrees. So that's 53.1 degrees. Or if you wanted to put this in radians, we could convert it to radians. In radians, C would be 0.9, and I'll round it to 2 decimals. Okay, so whatever your teacher wants you to do, you can either put this in degrees or you can put it in radians. And for this video, I'll just go ahead and write the answer out with the degrees. So, well, I'll write it with degrees and I'll write it with radians. So we're going to get 3 sine x plus 4 cosine x is equal to A, or capital A, which is 5 sine x plus our angle C, which is 53.1 degrees. Okay. And then if we write that in radians, that's going to be x plus 0.93. Okay. So, either one. So this is your answer with angle in degrees. This is your answer with your angle in radians. So I hope that helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.